in the middle of infinity, there is a strange object flying past our Sunday. No one knows where it came from. No one knows why it came. But perhaps it carries with it the story of a place beyond all the stars. Close your eyes for a moment and imagine in the depths of space where the sun's light is just a tiny dot, a lonely object drifts through our solar system. We call it 3I Atlas, an interstellar visitor, meaning it wasn't born here. It comes from somewhere else, so far away that the light from the star it departed from might take hundreds of thousands of years to reach us. Hello, and welcome to Moonwhisper Sleep, where science touches slumber and the universe becomes a lullaby of light. Maybe today has been a long day, or maybe you're someone who loves to let your mind drift freely into the night, among distant planets, silent moons, and the fragile sound of the universe breathing. Wherever you are, no matter how weary your thoughts may be, tonight, this journey is for you. Let your breath slow down. Let your thoughts dissolve like stardust in the air. And let your body grow lighter, as if gravity itself had loosened its gentle hand. And you begin to float softly across the ocean of space. Tonight's journey. Tonight, we'll cross the delicate boundary between science and consciousness, where invisible waves carry not just data, but awareness. When you close your eyes, your brain emits a frequency of 8 Hertz, the same rhythm as Earth, and also the rhythm that Atlas, the Interstellar Wanderer, once sent back from the red star skies. Let us listen together and see what happens when a planet begins to breathe, and when human consciousness itself vibrates in harmony with that rhythm. Tonight, you will understand why a single grain of dust can travel for billions of light years, why a tiny block of ice can carry the history of stars within it, and why even in this very moment, the light reflected by Atlas might be ancient light from when the universe was newly born. There is no need to rush, no need to understand right away. Just let your body drift through cosmic space. Let the whispers of the stars guide you and allow light to reach the deepest corners of your mind. We will listen to the faint winds from distant worlds, planets born from the same cloud of dust as Earth, where ancient light still travels through darkness, and where every grain of dust, every planet, tells us a story about time, life, and ourselves. Feel how the universe continues to move, calmly, vast, and patient. Each of your breaths is a tiny note in that grand cosmic symphony. If this stillness makes you smile, please like, subscribe, and ring the little bell, so that each night the universe may find its way back to you through the gentle whispers of Moonwhisper Sleep. And perhaps your small gesture might become a signal guiding someone who lies awake in the dark to discover this place, a place to rest, to learn, and to be cradled to sleep by the universe, one soul at a time. Now, take a deep breath, release everything that still lingers from your day, and let the channel guide you through the layers of space, where we don't just watch the universe, but begin to see ourselves in every one of its movements. Imagine this, in the darkness of deep space, where light takes thousands of years to find its path, an object drifts silently through our solar system, quiet, solitary, and almost invisible. No one knows where it came from. No one knows how far it has traveled. We only know that, for these few short months, it is here, near our sun, and then it will leave, forever. Astronomers call it 3I Atlas, the third interstellar object ever discovered by humankind. The letter I stands for interstellar, objects that come from the vast space between stars, where the pull of any single star no longer dominates. 3I Atlas was not born in our solar system. It is a wanderer, a fragment of memory from a distant place where other stars have died and the remnants of their matter drift endlessly through eternal darkness. When did humanity first see it? In early July 2025, a network of telescopes in Hawaii, Chile, and South Africa, part of the Atlas project, asteroid terrestrial impact, last alert system, detected a faint point of light moving slowly across the sky. They were used to observing such objects: asteroids, comets, fragments of meteorites, all orbiting the sun in predictable paths. But just a few days later, they noticed something unusual. This object was moving too fast. Every planet in the solar system is held by the sun's gravity, and their orbital speeds aren't random. The closer you are to the sun, the faster you must move. That's why Mercury speeds along at 48 kilometers per second, while Earth moves at 30 kilometers per second. Move too slowly, and you fall into the Sunday. Move too fast, and you escape forever, beyond the gravitational well of our central star. And Atlas was faster than them all, nearly 58 kilometers per second, while still farther out than Jupiter's orbit, meaning it had already exceeded the solar system's escape velocity. The scientists stared silently at the data. It wasn't an asteroid. It wasn't one of our comets. It was something from beyond, passing through our solar system, never to return. The third visitor in human history, 3I Atlas, is the third on this rare list. Before it, we welcomed two other guests, Oumuamua, 2002, and 2I, Borisov, 2019. Oumuamua, meaning the first messenger from afar, in Hawaiian. It was the first interstellar object ever detected. It passed so quickly that by the time humanity realized it, it had already left the solar system. No one managed to observe it closely. Its shape was elongated, like a spacecraft, and it had no tail like a comet. Some speculated it was a dry metallic rock, others perhaps a fragment of alien technology. 2 years later came Borisov. Unlike Oumuamua, it had a long, luminous tail, a true comet, yet its chemical makeup was entirely different from any comet found in our solar system. And then, in 2025, Atlas arrived. Larger, faster, and stranger than anything we had ever seen before. When Atlas approaches the Sun, by late October 2025, Atlas reached its closest point to the Sun, a stage known as perihelion. That distance was 1.4 astronomical units, about 210 million kilometers, still beyond Mars's orbit. At that range, the surface temperature of Atlas began to rise sharply. The layers of ice covering it, water ice, CO2 ice, and frozen compounds preserved for billions of years, began to sublimate. They didn't melt as they would on Earth. In the vacuum of space, water cannot become liquid. It transitions directly from solid to gas, a phenomenon known as sublimation. As these materials vaporized, they formed a hazy cloud around the rocky, icy core of the object. Astronomers call this cloud the coma, and when the solar wind blows through it, it creates a long tail trailing behind, like a soft streak of light brushed across the black canvas of space. Imagine this: the sun, more than 200 million kilometers away, still powerful enough to awaken and melt ice that has slept for billions of years. Fragments of Atlas, microscopic grains of dust and frozen crystals, rise from its surface, lifted away, carried by sunlight. It is a symphony between light and matter, a silent dance, unfolding in perfect stillness. If we could hear it, perhaps we would hear the hiss of vapor, the rolling of dust across rock, and the faint, distant breath of the Sunday. Sadly, when Atlas reached perihelion, our Earth lay on the opposite side of the Sunday. The blinding glare of our star made observation impossible. Even the most powerful telescopes, Hubble, James Webb, had to wait. We could only calculate and simulate, knowing that on October 29, an object from beyond our galaxy was passing near the sun, bathed in its radiation, like an ancient candle igniting for the first time. After billions of frozen years, why did Atlas come here? And why is it moving in a trajectory almost perfectly parallel to the plane of the solar system? A rare phenomenon, indeed. To understand this, imagine the solar system as a thin disk. All planets, asteroids, and comets lie roughly on that plane, which we call the plane of the ecliptic. Normally, interstellar objects enter on random, tilted, or intersecting paths, but Atlas strangely moves almost parallel, deviating only about 3 degrees. A coincidence so perfect it seems intentional. If the universe were a grand sheet of music, then Atlas is not a dissonant note, but a melody harmonizing with the rhythm of the planets. The arrival of 3I Atlas is a rare gift for science, because it carries not just frozen dust, but the chemical memory of where it once belonged. Objects like this are living samples from other star systems formed billions of years ago, when their parent stars were still burning brightly. Then, perhaps after a massive collision, or the gravitational tug of a giant planet, Atlas was ejected from its orbit, cast away from its home star, and began drifting through the interstellar medium, a place so cold it reaches 270 degrees Celsius, just above absolute zero. It wandered in darkness for billions of years, until a faint pull from the sun's gravity drew it gently into our system, only to pass by and vanish once more into the endless night. So what makes it different? When astronomers observed Atlas, they found it wasn't an ordinary comet. The light reflected from it showed an extremely strong negative polarization, something never seen before in any known object. Usually, sunlight reflected from dust or ice becomes positively polarized, meaning the scattered light spreads perpendicular to its source. But with Atlas, the light bounced straight back, a negative polarization that reveals its dust and material structure are unlike any comet in our solar system. This led scientists to believe that 3I Atlas may have formed in an extraordinarily ancient environment, perhaps within the thick disk of the Milky Way, where old stars reside and where there are almost no new collisions or supernovae. If that's true, then Atlas may be over 7.6 billion years old, nearly twice the age of Earth, a true relic, carrying within it the dust and ice from a time before our sun was even born. Throughout its long life, Atlas may have drifted past hundreds of stars, but seldom approached any closely. Calculations show that in the past 10 million years, its nearest pass to another star was about 0.3 light-years, around 63,000 astronomical units, and now it's just 1.4 AU from the Sun, closer than the distance between Earth and Mars. A journey spanning billions of years, only to glide through the light of a foreign star, then disappear into darkness once again. And as you hear these words, 3, Atlas is still drifting, silent, directionless, unseen. Perhaps, in some fleeting moment, the sunlight reflected from its surface will slip through the wall of solar plasma and reach the lens of a distant satellite, and one day we'll see it again, on the far side of the sun, as it begins its departure from the solar system, carrying secrets that only it knows. In the vastness of the cosmos, a solitary shard of ice is melting, a solar wind is blowing, and astronomers continue to watch, knowing that every object, like Atlas, is a quiet reminder. We are not alone in this universe. It's just that. The other travelers are far too silent for us to hear. As the sun's light fades behind Earth's curve, telescopes still silently aim upward, tracking a faint point of light receding by the minute. That is 3I Atlas, the third interstellar object humanity has ever encountered, an ancient shard of ice that has just passed by our star and now drifts back into the cold void between the stars. But what makes Atlas special is not only that it came from somewhere else, but the very way it arrived. Our solar system, seen from afar, looks like a giant flat disk. The sun sits at the center, and around it, concentric rings. Mercury, Venus, Earth, Mars, all moving on nearly the same plane, called the ecliptic plane. Typical comets, or interstellar objects, often travel on inclined or offset orbits, sometimes swooping in from above or below this plane. But Atlas is different. It entered the solar system almost perfectly parallel to the ecliptic, deviating by only about 3 degrees. That means, if you were to draw the orbits of the planets as circles around the Sun, Atlas's path would nearly overlap that same plane. A coincidence so precise, it's almost impossible to be random. Like a pebble thrown perfectly through the narrow gap between planets, Atlas sliced across the solar system in a T-bone trajectory. A flawless crosscut, perpendicular to our direction of travel around the Sunday. This was not the same path as any previous interstellar visitor. Both Oumuamua and Borisov came from the north of the solar system, aligned with the direction of the sun's motion through the Milky Way, but Atlas approached from the side, as if it had been waiting, right in our path, a probability so rare that astronomers have called it a near-intentional coincidence. Atlas's siblings, To understand why Atlas matters so much, let's look back at its two predecessors. Oumuamua, discovered in 2017, a small object about 400 meters long, without a tail and reflecting light in a strange way. As telescopes tracked it, they found its speed increased slightly, even as it moved away from the sun, as if an invisible force were pushing it along. Not the solar wind, not rocket-like thrust, and certainly no sublimating gas like a comet. That led to countless hypotheses that it might be an ancient spacecraft, an abandoned light sail, or simply a peculiar evaporating material that humanity had never seen before. 2 years later, Borisov, 2I, appeared. Unlike Oumuamua, Borisov was clearly a true comet. It had a long tail, venting gas and dust as it approached the Sunday. It looked ordinary, but spectral analyses showed its chemical composition was markedly different, especially in the ratio of CO2 to H2O. This proved that other star systems can also form comets, but by a recipe entirely different from ours. And then Atlas arrived, larger than both, twice as fast, and bearing characteristics that combine both earlier objects. It resembles a comet, yet behaves unusually like Oumuamua, the first discoveries. When it was discovered on the 1st of July 2025, Atlas was inside Jupiter's orbit, about 4.5 astronomical units, AU, from the Sunday. The first data showed it reflecting light more and more strongly, as if it were waking up. Scientists used TESS, Transiting Exoplanet Survey Satellite, to track changes in its brightness. Over the course of a month, Atlas moved nearly 1 AU toward the Sun, and its brightness increased 5-fold, 3 times stronger than initial predictions. That indicated it wasn't a bare rock, like an asteroid, but a comet beginning to sublimate. Unusual chemical composition. When infrared telescopes scanned the halo around Atlas, they detected a very high ratio of CO2, 8 times higher than water vapor, H2O. This is extremely unusual, because most comets in the solar system are the opposite. Water dominates, CO2 is only a minor component. This is a sign that Atlas formed in an extremely cold environment, possibly at the far edge of its parent star system, where temperatures are so low that CO2 can freeze before water. You can imagine CO2 in the form of dry ice, like what we use to make stage fog. When you take dry ice out of a cold environment, it doesn't melt, but evaporates immediately, creating that characteristic mist. Atlas is doing the same, but at a distance of more than 700 million kilometers from the Sunday, metals from a dead star. When the light was analyzed more deeply, scientists detected the presence of nickel, Ni, but no iron, a puzzling phenomenon. Normally, nickel and iron are produced together in the cores of supernova exploding stars. They are the universe's twins, rarely separated. Yet in Atlas, there is nickel without iron. Perhaps, over billions of years, collisions or thermodynamic processes in space separated them. Or perhaps the place where Atlas was born was already iron poor when its parent star was young. This has led many astronomers to believe that Atlas is not just a foreign object, but evidence of an ancient world formed from a type of star, very different from the Sunday. When the solar wind touches it, as Atlas approached the Sun, something strange happened. Its tail did not point away from the Sun, as usual, but instead pointed back toward the Sunday. That is a phenomenon never seen in any comet. At first, scientists were perplexed, but then they realized, because Atlas had begun sublimating from very far away, its surrounding CO2 gas was too thick and dense, while the solar wind at that distance wasn't yet strong enough to blow it back. As a result, the gas accumulated toward the warmer side, the sun-facing side, creating a reverse-pointing tail. A few weeks later, as Atlas moved deeper inward, the solar wind strengthened and its tail swung back to the normal position, becoming a short, fan-shaped plume extending outward. A majestic scene that only telescopes beyond Earth could observe. A view from Mars. On the 3rd of October 2025, Atlas passed by Mars at a distance of 0.19 AU, closer than to any other planet. From the surface of the red planet, the Perseverance rover tried to photograph it. Of course, it couldn't be sharp. The image was just a faint streak, captured by stacking multiple frames over 30 seconds. At the same time, the ExoMars orbiter of the European Space Agency also pointed its lens skyward, recording a small streak of light gliding by, like a star moving among motionless stars. Perhaps at that moment, if someone had stood on Mars and looked up, they would have seen Atlas as a thin ribbon of light drifting slowly across the night sky. A strange visitor, arriving and departing, carrying the memory of another world. As Atlas moved away from the Sun, it left behind a fading tail, a stream of dust and tenuous gas, dissolving into the space between Mars and Jupiter. In December 2025, as it slipped out of Earth's view, scientists would have another chance to observe it, when it reappears on the far side of the Sun, reflecting light back toward us. By March 2026, Atlas will pass Jupiter at a distance of 0.36 AU before leaving the solar system forever. If the Juno probe is still operational, it may capture the final images, the last moment humanity sees this visitor. By then, it will return to its original frigid state, sleeping in the darkness of space, waiting millions of years before it might meet another star. Perhaps, somewhere out there, another distant civilization will see it, streak across their sky, and wonder as well, where did this object come from? And so, Atlas's journey continues, a circle with no beginning, no ending. In that stillness, there is something that renders us silent. We, small creatures living on a blue planet, are watching a speck of dust travel among the stars and realizing everything in this universe is in motion, from the planets to the very thoughts within our minds. If you close your eyes and listen carefully, perhaps you too will feel a gentle beat in your chest, in harmony with the far-off journey of 3I Atlas, a reminder that we, like it, are only temporary travelers among the stars, among the hundreds of billions of stars in the Milky Way. 3I Atlas is just a tiny grain of dust, yet that grain carries the memory of the universe's earliest days. As astronomers traced its path back across millions of light years, they found Atlas did not come from the youthful, thin disk of the galaxy, where the Sun and Earth reside, but from a much more ancient region, the region known as the thick disk. The Milky Way's thick disk, the dwelling place of ancient stars. If you look at the Milky Way from the side, you will see a glowing thin disk. That is where most stars, planets, and gas dust are concentrated. But surrounding it, above and below that thin layer, is a thicker, paler region, strangely quiet. That is the thick disk, the realm of elderly stars formed more than 10 billion years ago, before the Sun was born. There are no longer violent supernova explosions, no longer the powerful gravitational storms of young star clusters. Everything is reduced to stillness and the ancient remnants of a time when the galaxy was still learning to balance itself. According to dynamical models, 3I Atlas was very likely born in that thick disk region where the material density is low, temperatures are cold, and the environment so stable that an object can survive for billions of years without collision or disintegration. Atlas's estimated age may be up to 7.6 billion years, nearly twice that of Earth. It may have formed when our Sun did not yet exist, when the Milky Way was still turning slowly in the dawn of time. Because it hails from that region, Atlas's chemical structure is also very different from comets in the solar system. The comets around us are formed mainly from water ice, H2O, frozen in the outer portion of the protoplanetary disk, where Neptune and Pluto dwell. They contain a little CO2, CH4, NH3, and simple organic compounds. But Atlas is the opposite. It almost inverts the recipe. CO2 dominates overwhelmingly, while water is only a minor additive. This shows that its formation environment was far colder, possibly below 220 degrees Celsius, where even carbon dioxide freezes into solid rock. When warmed by sunlight, these CO2 ice patches evaporate rapidly, releasing billions of tiny gas particles into space and creating the hazy halo we see. That is not just a physical phenomenon, but a revival of an ancient world, warmed for the first time after billions of years buried in the cold night. When sunlight reflects through the dust around Atlas, it reveals a surprise. That light is negatively polarized, meaning most of the rays bounce back toward the light source, instead of scattering outward like ordinary comets. This means the dust grains around Atlas have ultra-fine structure and reflect light in a way that can only form in an extremely tranquil environment where there are no major collisions or disturbances. In fact, among tens of thousands of observed objects, Atlas exhibits the strongest negative polarization ever recorded, like a distinct hallmark, an optical signature, declaring, "This is something from a place we have never touched." When humans look back through time, when astronomers simulated Atlas's trajectory, they could trace it back more than 10 million years and found it had passed by at least 93 other stars. But the astonishing point is, the closest distance between Atlas and any of those stars was never less than 0.3 light-years. That is, more than 63,000 astronomical units, AU. This means, for millions of years, It has never been drawn close to any other star. A solitary journey, complete, without collisions, without course changes, like a traveler crossing an endless ocean with no harbor, only the far light of the stars as companions. In the language of the cosmos, time and distance are inseparable. For Atlas, every kilometer it travels also means traveling back through thousands of years of history. If you could follow it, you would see the epochs of the galaxy passing by, the formation of second-generation stars, the birth of water-rich planets, and distant supernovae igniting the night. Atlas has witnessed it all, but it carries no memories in words, only in chemistry, light, and ice. It is a book without letters, but every grain of its dust is a line of notes about the young universe. There is an interesting point. In physical models, the sudden temperature rise when a comet approaches the sun causes its outer layer to evaporate, but the inner core retains the original composition from the day it was born. That means 3I Atlas is letting us glimpse the past. As CO2 and H2O escape, they carry traces of the isotopic ratios of oxygen, carbon, and hydrogen, the keys that help scientists determine the chemical environment of the parent star. If those ratios differ sufficiently, we can determine Atlas not only comes from another star system, but from an entirely different generation of stars, an older cosmic era where matter had not yet been mixed by recent stellar explosions. In other words, Atlas is a fragment of an ancient galaxy drifting within a universe that has changed vastly since it was born. It is strange to think that after billions of years wandering in darkness, that object happened to encounter our solar system right at the moment when humanity had just become intelligent enough to recognize it. If Atlas had passed by only a few thousand years earlier, when humans did not yet know how to look up at the sky, it would have slipped by in silence, unnamed, unknown. But today, we have telescopes, spectrometers, and a network of satellites reaching all the way to Mars's orbit. And thanks to that, a mote of dust from the prehistoric era of the universe has been seen, named, and had its story retold by us. When you look up at the night sky, the starlight you see set out thousands of years ago. Some of those rays may have shone through 3I Atlas, then bounced back and are now touching your eyes. You are watching the universe look back at itself through a small mirror of ice and dust, drifting in the endless void. Atlas is only a brief spark of light, but it reminds us that everything in the universe is connected by the same thread of energy: light, gravity, and curiosity. Then it will go far away, leaving the sun's sphere of influence, crossing Jupiter's orbit in 2026, and gradually growing cold until all is quiet again. But that journey does not end, because somewhere, hundreds of millions of years from now, it will again pass by another star, and another civilization will discover it, and they will ask the same question we ask today. Where did it come from? And what story of the universe does it carry? Let your mind settle. In the gentle darkness of the night sky, 3I Atlas is receding, like a whisper slipping past the sun's ear. We call its path a super hyperbola, an open curve, never closing, a journey with only arrival and departure. At the level of celestial dynamics, What determines Atlas's fate is not only the speed it attains near the Sun, but the velocity at infinity, v infinity. If v infinity is greater than 0, the path will remain open. If v infinity equals 0, it stands on the threshold of falling back. If v infinity is less than 0, it becomes a child of the Sunday. For Atlas, v infinity is positive, meaning even when there is no longer radiation pushing it, even when everything has fallen quiet, it still belongs to the space between the stars. And the strange thing is, precisely as it departs, Atlas tells us the most. If we could zoom in on Atlas's surface, we would see an incredibly thin frontier between solid ice and vacuum, what is called the Knudsen layer, a region where escaping molecules interact more with the grain surface than with one another. There, microjets of gas spring straight up like invisible fountains, carrying fine dust and even rare metal atoms. In the cold regions far from the Sun, CO2 is the earliest to awaken. It evaporates, sublimates, at much lower temperatures than water, creating a thick coma already from 5 AU. Near 1.5 AU, H2O finally finds its voice, and in just a few weeks, the CO2H2O ratio can reverse, like two instruments taking turns to lead the melody. Uneven outgassing creates tiny non-gravitational thrust, which can nudge the trajectory slightly and also spin the object, altering its rotation period, like a tiny nozzle attached to a round block of ice. Behind that boundary layer lies a quiet concept: thermal skin depth. Radiation has time to warm only a thin surface layer during each cometary day-night cycle. Beneath it, the ice remains pristine, primordial, preserving the isotopic signature of the place where it was born. Therefore, when water vapor, or CO2, escapes, they are not merely gases, they are letters from time, carrying DH, Dune, Calci, Dunquoise, Dunchal, Dunchal, clues that can recount Atlas's chemical childhood around another star. A comet typically has two tails, a dust tail, bright, slightly curved, pushed back by radiation pressure on reflective grains, and an ion tail, thin, bluish, drawn out by the solar wind acting on ionized molecules. Atlas once did a contrary thing. Far away, it had a tail pointing toward the Sunday. That was not magic, but physics. When CO2 erupts in a region where the solar wind is still weak, the dense coma is herded by thermal contrast toward the warmer side, the sun-facing side. Farther in, the wind grows stronger. The interplanetary magnetic field sweeps in. The ion tail reclaims the rule and swings away from the sun as usual. On the brightest days, photolysis products appear in Atlas's coma. H2O is cleaved by ultraviolet light into O. Hence, OH is often a proxy for measuring water. CO2 and CO reveal themselves via infrared absorption bands around 4-5 micrometers. Under sunlight, carbonaceous fine dust becomes glossier, snowflake-like. Fluffy aggregates scatter light very differently from smooth, compact grains. And that is a clue to Atlas's unprecedented strong negative polarization. That effect has two resonant mechanisms: shadow hiding opposition effect and coherent backscattering. When the observing phase is near, opposition Sun-Atlas telescope nearly aligned, the tiny shadows among dust grains vanish, and the scattered waves coherently enhance one another in the backward direction. The result is light that seems to skim the surface and return the way it came, creating Atlas's very own optical fingerprint. A kind of aesthetics of physics we rarely get to see. Nickel first, iron later. The paradox of flying metals. From far out, spectra once saw Ni without Fei. In the universe, Ni and Fei are twins born in the hearts of exploding stars. Separating them is not easy. The most plausible explanation: a strong CO2 outflow drags along an amount of Ni that either evaporates or is torn off grain surfaces, while Fei, in its phase or mineral compounds, is harder to free under those temperatures. Closer to the Sun, the thermochemical system crosses a threshold. Fei begins to appear. The Ni-Fei ratio normalizes again. Behind a small deviation lies an entire plot of energy thresholds, where each element, each mineral, has its own schedule for leaving the surface. There are months when we are powerless because of the solar elongation. The target lies too near the Sun's disk in the sky, so telescopes cannot lock on without risking thermal stress and glare. That is the silent season of observation. But science grows from patience. By early December, Atlas slips out beyond the glare angle, the 4.26 micrometers, CO2, and 4.7 micrometers. Bands are ready again. The OH emission lines signal water. The brightness declines continuously, exponentially, as energy departs the surface. That fading is not loss, but a return to the primordial state, once more preserving the chemistry of the core, so that at the next warming by another star, perhaps hundreds of millions of years from now, it will be ready, projected for March 2026. 3I Atlas will sweep past Jupiter at about 0.36 astronomical units. For an interstellar guest, that is just a gravitational blink, enough to bend the path slightly, but not enough to hold it. If, by then, the probes around Jupiter can swing their cameras, we may obtain Atlas's final portrait. When the dust tail is thin, the ion tail weak, and the water flux waning, from a roaring fire hose to a first light morning mist, suspended in a distant glow. And after that brief rendezvous, Atlas will keep drifting, leaving Jupiter's sphere of influence, crossing the boundary of sunlight and sinking into the cold space where there is no day or night. Then it will return to its primordial stillness, where light is only a memory and every motion tends toward the infinite. We will no longer see it, but part of the light it reflected will remain in data, in memory, and in the curiosity of those who once looked up and asked, perhaps, somewhere out there, countless other visitors are passing by in silence, carrying other fragments of the universe's memory. In celestial mechanics, such close sweeps are natural tests. If Atlas has unstable fragments or asymmetric sublimation regions, torque from the gas flow can change its rotation period, producing short outbursts. But with a distant perihelion, 1.4 AU, Tidal stresses are small. The risk of splitting like sun-grazing comets is low. Physics is sometimes that gentle. As if the universe, too, wishes to keep a relic intact. Over billions of years between the stars, Atlas's surface endures cosmic radiation. Ice is amorphized, chemical bonds crack, generating radicals and prebiotic compounds. When sunlight arrives, photochemical chains spring to life, releasing HCN, C2, NH2 at faint levels in the spectra. Each emission line is a sentence, each isotopic ratio a stressed syllable. We can read the irradiation history of interstellar space, read the weathering rate of dust, and sometimes read the very prebiotic bricks that might one day have seeded far-off worlds. Some ask, if an object sweeps by and disappears, what is there to care about? But science is the art of the right moment in the right place. Each pass-by, like Atlas, is a traveling experiment sample delivered by nature. We cannot fly to every star, but sometimes their matter comes to our window, bringing their ice recipe, bringing their isotopic ratios, bringing the chemical music of a place we have never set foot in. On the philosophical plane, this is a lesson in coming and going. Every orbit is temporary, every revolution a meeting of fate, every encounter enough to teach us one more thing about the world and about ourselves. We look at Atlas to understand the galaxy, but in the silence of observation, we also hear the breath of curiosity within. Imagine you are standing in a dark field, no moon, a very light wind. Above, the star bands flow like cold rivers. Somewhere, unseen, Atlas is fading, carrying a portion of our sun's light into the deep night of the galaxy. Like it, we are travelers, through days and nights, through the seasons of a life. The universe does not hurry. It simply continues. And in that continuance, a dust grain that knows how to sublimate, a gas tail that knows how to change direction, a spectral line that knows how to whisper, are enough for you to sleep peacefully tonight. Breathe slowly. Let your eyes grow heavy. If, in your sleep, you see a small streak of light cross the pitch-black sky, smile. You have just met Atlas again. In the memory of light, have you ever wondered, how do astronomers know an object is interstellar? When the sky is full of comets, how do they recognize a stranger? How do we know Atlas came from outside the solar system? The answer lies in the orbit. Every object bound to the sun follows a closed ellipse, like Earth, Mars, or long-period comets. But Atlas's orbit opens to infinity with an eccentricity greater than one, that is to say, hyperbolic. In the mathematical language of the cosmos, that means it is unbound. Even with the sun gripping it by gravity, Atlas still has enough energy to escape, like a speck shot out from the ocean of stars. Scientists measure Atlas's velocity at infinity, v infinity, and find it exceeds 26 kilometers per second. The threshold speed required never to return. At that speed, nothing in the solar system can hold it. Why is the light from Atlas negatively polarized? In space, light is usually scattered when it meets dust grains. If the light emerges at right angles, it carries positive polarization, what we usually see in comets. But if the light reflects backward toward the source, it is called negative polarization. This phenomenon is very rare. It occurs when dust surfaces are extremely fine and porous, to the point that photons do not scatter independently, but resonate in reverse with one another, like dewdrops on a spider web at dawn. When the sun rises, the light does not spread outward, but turns back, making the silken threads glitter more intensely. Atlas exhibits the strongest negative polarization ever measured. This reveals that it may have been born in an extremely cold, tranquil environment, where dust is not collision processed, a primordial laboratory of the universe. Why do comets breathe with cold vapor? When a comet approaches the sun, its surface temperature rises rapidly. But instead of melting, its ice sublimates directly into gas, because in a vacuum, water cannot exist as a liquid. That's why a comet seems to breathe. Each molecule of water, CO2, or ammonia, leaves the icy surface, like a breath exhaled from an ancient body. In Atlas, CO2 sublimates earlier than water, even when it's still 5 AU from the sun, more than 700 million kilometers away. CO2 is a more heat-sensitive gas, so it awakens first, forming an early, thick cloud of gas around the icy core, making Atlas glow brighter than expected. Why is there nickel but no iron? An intriguing mystery. Both Ni, nickel, and Fe are born together in the cores of supernova explosions. Therefore, normal comets always contain both. Yet in Atlas, when first observed, scientists detected Ni but not Fe, the most reasonable explanation. The CO2 outflow was so powerful that it carried Ni off the surface, while Fe remained locked within tougher mineral structures. Only when Atlas came closer to the sun, as temperature rose, did iron begin to vaporize. This is not just a minor chemical detail, but evidence of the object's thermodynamic history. It reveals that its crystalline structure is different, and that Atlas may have gone through multiple cold, warm, cold cycles in space. Why do comet tails always point away from the sun? Except Atlas. A comet's tail isn't a trail. It leaves behind, like a moving car. It forms because the solar wind and radiation pressure push the gas and dust away from the sunlight. That's why, no matter which way a comet travels, its tail always points away from the sunday. But in Atlas's case, when it was still distant, the solar wind was weak, while the CO2 jets were strong, causing the dense gas to accumulate on the warmer side, creating a reverse tail that pointed toward the sunday. Only when it entered the region of stronger wind did the usual rule restore itself. Science sometimes unfolds like a story. Before things become normal, they must first pass through a moment of strangeness. How do scientists measure the amount of water in a comet? When ultraviolet rays from the sun hit a comet, they break H2O molecules into OH, hydroxyl. OA glows at a wavelength of 308 nanometers, and that's the telltale signature of water. Telescopes don't see the water directly. They detect the light from OH, then deduce the original H2O amount. In Atlas, by September 2025, the OH levels corresponded to thousands of liters of water per second. like a massive silent flamethrower burning in space. That's more water than any interstellar comet ever recorded. Where is Atlas going? With a speed exceeding 58 kilometers per second, Atlas has escaped the Sun's gravitational influence. After passing perihelion, it's heading toward the outer reaches of the Milky Way on a trajectory that will carry it permanently out of the solar system. Simulations show that over the next 10 million years, it will travel through frigid space, sometimes passing near a distant star, then being pushed away again, never finding a place to rest. And perhaps, one very distant day, it will pass through another star system, and beings there will call it by another name. Another way of asking the same question: where do you come from? Why are objects like Atlas important? Because they are living proof that the galaxy exchanges matter. Interstellar comets carry dust, gas, metals, and even primitive organic molecules, the building blocks from which life may arise. We, the humans sitting on Earth, may have been formed from matter that once drifted among the stars like Atlas. Every atom in your body was once part of a dead star. When we observe Atlas, we are, in fact, looking at our own past. And the final question: when Atlas disappears, what remains? Not light, not the dust tail, but the awareness that we have witnessed something real in the universe. An object that traveled for billions of years to reach this place, and that we were lucky enough to see that moment. In physics, there are no miracles, but in emotion, all understanding becomes light. And sometimes it is that very light, the light of understanding, that allows us to sleep peacefully beneath the vastness of the cosmos. Perhaps 3i Atlas never knew it was being observed. It carries no mission, no message, and seeks no one. It simply drifts through billions of light years across regions of space where even light grows weary. Yet precisely because of that absolute silence, Atlas has taught us something that perhaps all intelligent life must relearn many times. That life is not a destination, it is an orbit. In physics, there is no such thing as absolute rest. Even when you think you're sitting still, Earth spins beneath your feet at nearly 1,600 kilometers per hour and orbits the Sun at 30 kilometers per second. This entire planetary system hurtles around the Milky Way's core at 220 kilometers per second, and our galaxy itself drifts through intergalactic space. Everything moves. Everything is traveling. Atlas is simply part of that dance. A longer, lonelier step, but still moving to the same cosmic rhythm. When we see it, we are also seeing ourselves, flying along the orbit of change, passing through the seasons of matter and of mind. Solitude is not emptiness. Atlas passes through the solar system only once, then disappears into the dark. Yet, in that journey, it carries the sun's light, absorbing, reflecting, and sending out its final rays before it departs. Physics calls this albedo, the reflectivity of a surface. But if we look deeper, it is also a beautiful metaphor. Every solitude can become a reflection of light when it meets a warm source of energy, just like humans. When touched by the light of compassion, we begin to shine, not because we wish to be seen, but because we cannot help but radiate. When Atlas formed, our sun was still a cloud of dust, and when it departs, Perhaps the sun itself will have gone dark. On the scale of the universe, a planet, a star, a civilization are all fleeting beams of light. But the wonder is this: even if brief, the universe remembers everything in photons, in dust, in gravity's fields. Nothing is lost. Everything only transforms, just like Atlas, from solid ice to gas, then dissolving into light. If eternity exists, it is not in form, but in continuity. In physics, that is the law of conservation of energy. In life, it is the flow of awareness and compassion. Science is also a form of meditation. Many believe that meditation means letting go of all thought. But in science, there are moments of silence just the same. When we gaze at an orbit, a light spectrum, a single number in a data table, and suddenly feel the order hidden within chaos. Science is not merely measurement. It is the art of attention. Every person who observes the sky is also observing themselves. The curiosity, the wonder, the boundless astonishment that the universe has planted in our DNA since the moment we were born. Perhaps that, in itself, is the bridge between physics and spirituality. Both begin with awe before beauty. We are also interstellar travelers. When we say Atlas came from the stars, remember that Earth itself is traveling among them. Every atom in your body, the hydrogen in your blood, the iron in your cells, the carbon in your breath, once lay in the heart of an exploding star billions of years ago. You are stardust that has become self-aware. When you look up at the sky, the universe is looking back through your eyes. We are not merely living in the universe, we are the universe, learning to understand itself through the language of consciousness. Light never truly fades. One day, Atlas will vanish completely from sight. It will grow cold, dim, and drift into a region of space without light. But the sunlight it once reflected, those tiny photons, will keep traveling forever, beyond the galaxy, carrying a trace of the moment it once existed. If someone, somewhere, in a distant galaxy, one day catches a faint beam of light bearing the fingerprints of the sun and Atlas, they will know there was once a meeting between two worlds. In physics, that is the nature of light. It does not age, tire, or die. In humanity, that is the nature of gratitude. It too never fades, only changes form into memory, faith, and peace. And now, as you hear these words, Atlas has already gone far away. But distance does not mean separation. Distance is simply another way for light to learn how to move. Perhaps, in tonight's stillness, the universe is gently whispering to you, "You are not alone. I have been with you since the first dust was born." Let your breath slow. Feel each heartbeat. It is the faint echo of billions of years of evolution and the perfect mirror of the rhythm carried by the stars. If Atlas leaves behind anything, it is the reminder that every journey, long or short, helps the universe know itself a little more. 3. I, Atlas, the interstellar traveler. Not merely a block of ice, but a poem of physics written in light and spoken in the language of wonder. If you fall asleep peacefully tonight, let your dreams follow the curve of its orbit, to go, to depart, and to return. to the stillness within yourself, where the universe continues to whisper, "I am light, and so are you." Perhaps right now, somewhere beyond the reach of light. 3. Atlas has sunk into the cold night between the stars. No more sunlight, no more glowing tail, only a silent block of ice, drifting through infinity, like an unspoken thought of the universe. But to us, it is still here, in the numbers, in the spectra our telescopes recorded, and in each breath of curiosity. Every time a human being looks up at the sky, a part of Atlas is reborn through our gaze, our questions, our yearning to understand why we exist in this world. If you are still awake, let your breathing align with the Earth's slow rotation. Out there, everything is still in motion. Streams of plasma continue to rise from the sun's surface. Dust particles still drift gently in the moonlight. And somewhere in the vastness, perhaps another object is beginning its own journey, heading toward us. We will meet another visitor again and tell the story once more, the story of curiosity, of light, and of gratitude. If you have listened this far, allow me to say thank you for traveling across billions of years of light in just a few peaceful minutes. If you wish to hear more journeys like this, stories where science meets sleep, where the universe becomes a lullaby for the mind, subscribe to Moon Whisper Sleep and let the small bell beside it bring you back whenever the light begins to rise. Close your eyes. Let your breath dissolve into the slow rotation of the Milky Way. For out there, no distance is truly far. Every beam of light is finding its way home, just like Atlas, just like us. Sleep deeply now. The universe will dream with you.